Welcome back, everyone, to the deep dive. And
Yeah.
first off, wow, thank you. The response to our last deep dive on the general theory of intelligence was just uh, incredible.
It really was phenomenal. We saw so much engagement.
Yeah, and that was pretty abstract stuff, right? Thinking about thinking.
Definitely. But today, we're kind of flipping the script. We're taking that energy, that thinking about information and intelligence, and grounding it
Grounding it how?
in something real, something you can actually, build. We're moving beyond just talking about ideas or consuming content like podcasts or videos.
Okay, intriguing. So what are we diving into?
It's a collaborative product idea, really. An open source blueprint called Project Scribe.
Project Scribe, okay. And what's the core idea?
It's a blueprint for a very specific, almost niche kind of machine, an AI-native laptop. But it's more than just a gadget idea.
How so?
Well, the creators frame it as a movement almost, a call to arms to build something focused purely on creation, using AI, using specific hardware choices. It's about building hardware for better thinking.
An AI-native laptop for creation. What does that actually look like?
Okay, so picture this. It's a command line only laptop, no graphical interface.
Command line only. Wow. Okay. That is specific.
And it uses an e-ink screen. Designed specifically for deep work, for learning, especially outdoors. It's about stripping away everything else.
So minimizing distractions to maximize focus.
Exactly. The document itself, the blueprint, they call it a manifesto for the distraction-free AI-native laptop.
A manifesto, huh? That definitely sets a tone.
It does. It tells you right away this is philosophical. It's positioned as the complete opposite, the antithesis of the computers we use every day.
The ones bombarding us with notifications.
Precisely. So today we're going to unpack this whole thing, the why, the how, from the deep work philosophy behind it right down to the specific parts list, the bill of materials.
Sounds fascinating. Let's get into it. Where does the manifesto start?
It starts right where you'd expect with the problem, the core paradox of modern computing, that the computer is, arguably the most powerful tool humanity has ever created, access to everything.
Right. Infinite knowledge, connection.
But, and here's the paradox, it's also engineered for maximum interruption. It's maybe the most distracting tool ever created, too.
That definitely resonates. It feels like a constant battle for focus.
Exactly. And the manifesto points out the irony. The very people who need focus the most, writers, programmers, researchers, thinkers.
The target users for this Project Scribe device.
Right. Their primary tools are actively working against them. They're built for consumption, for clicking the next link, checking the next notification, scrolling the feed. It shatters that deep work, that flow state.
And it's not just a mental cost, is it? The manifesto mentions physical stuff, too.
Oh, yeah. They don't pull punches there. It's the obvious things like the constant notification stress, the endless feeds hijacking your attention.
But also the screen itself.
Yes. The physical eye strain, the fatigue from staring at bright, flickering, backlit LED screens for hours on end. Our tools are literally wearing us down physically as well as mentally.
So where did this specific idea, Project Scribe, come from? Was there a sort of aha moment?
The document mentions a personal experience from the project's originator. They apparently spent 2 whole years working only in a command line Debian environment.
2 years, just text.
Just text. And they describe the result as, and this is a quote, peaceful, profound productivity.
Wow. Okay, so that simplicity was the key.
That was the seed. Realizing you could do complex, demanding work without all the graphical noise, without the browser temptations, just you and the text.
So that personal experience shapes the vision for Project Scribe, a tool for pure thought, as they put it.
Exactly, unencumbered. And the specs reflect that. They envision a specific screen, 13.3 inches, e-ink.
E-ink, like a Kindle, but bigger.
Sort of, yeah.
Yeah.
But optimized for this use case. Critically, it's sunlight-readable. They say it feels like paper. Imagine working outside, clear as day.
That's a huge difference from my laptop screen disappearing in the sun.
Yeah.
And the battery life. That's always the killer.
They're aiming for week-long battery life.
A week? Seriously?
That's the goal, complete untethering, and it relies on that software minimalism we talked about.
Just the essentials.
Basic Debian Linux, just the core tools needed for writing or coding, Vim as the editor, 10mux for managing sessions.
We'll probably need to unpack 10mux a bit later.
For sure. And just standard command line utilities. No web browser, no fancy graphical apps.
Okay, so this brings us back to the e-ink screen. You mentioned the command line and e-ink. Why are they such a perfect match, according to this manifesto?
This is the core insight, they argue. It's a synergy that's been completely overlooked by the mainstream market.
How so? We know e-ink is low power.
It's about how e-ink works and what the command line demands. E-ink is amazing at displaying static images, like text, with high contrast. Looks like paper, sips power when static. The command line is, well, almost entirely static text, usually black and white monospace font. It only changes when you type a new line or scroll. Minimal changes.
Right, unlike a web page or video constantly refreshing.
Exactly. So e-ink's main weaknesses, slow refresh rates, potential for ghosting, they become almost irrelevant in a pure text environment. The display barely needs to redraw.
And the lack of color doesn't matter in a terminal.
Nope. It completely negates the limitations. So you get this perfect combination, eliminates glare, perfect outdoor readability, and incredibly low power draw because you're only refreshing tiny bits of the screen occasionally.
It's the ultimate combo for focused text work.
That's the argument. The interface simplicity directly enables the hardware efficiency.
Okay, so the philosophy dictates these constraints, but achieving them, like week-long battery life,
Yeah.
that sounds like a serious engineering challenge.
Oh, absolutely. It requires a ruthless focus on efficiency at every single step, which leads us neatly into the engineering rationale.
All right, so the engineering. If week-long battery is the dream, what's the guiding principle?
One principle, above all else, the relentless pursuit of power efficiency, particularly idle power efficiency.
Why idle power specifically?
Because think about the workflow they're targeting. Writing code, writing prose, it involves long stretches where you're just thinking, staring at the screen, pausing.
Right. You're not constantly typing or compiling. There's a lot of, well, idle time.
Exactly. So the absolute #1 goal, the most critical objective, according to the blueprint, is minimizing how much power the device uses when it's just sitting there waiting for you.
Makes sense. Even small drains add up over a week.
Yeah.
So where does that focus lead them first? What's the biggest power hog?
The display. Always the display. And this leads to their first major critical technical decision. How to connect that e-ink screen. It's SPI versus HDMI.
Okay, HDMI is standard for monitors.
Yes.
Why don't I just use that? There are HDMI ink monitors out there.
There are, but they fail the efficiency test for this project.
Yeah.
Completely.
Why is that?
It's fundamental. HDMI requires the computer, the little single-board computer, SBC, inside, to constantly generate and blast out a high-speed video signal.
Even if the picture isn't changing.
Even if it's static text, the monitor has to constantly listen for that signal. Both ends are burning power, just maintaining the link. It's inherently inefficient for a device that's mostly idle.
Okay, so that's a non-starter for week-long battery. What's the alternative? You said SPI.
SPI, Serial Peripheral Interface. It's a much lower level way to connect. They plan to use an e-ink HAT, that's hardware attached on top, which connects directly to the SBC's GPIO pins.
GPIO, the general purpose input-output pins.
Exactly. This direct connection is crucial. It's non-negotiable because it gives the software deep, low-level control over the display controller.
Unlike HDMI, which is just a dumb pipe for video.
Precisely. With SPI, the software can tell the display controller, okay, nothing's changing, go into deep sleep now, and it can power it down to consume almost zero electricity.
Until the next keystroke or scroll demands a refresh.
Yes. And in a command line, that could be seconds or even minutes later. That ability to fully sleep the panel between updates is the key to hitting that multi-day or week-long target.
That sounds specialized. Does that specific component cost a lot?
It does. The document actually names it. The WaveShare 13.3-inch e-paper HAT SKU 15853. And the estimated cost is around $408.
Wow, $408 for just the screen controller. That's a huge jump to the budget.
It is, more than half their estimated prototype cost. But it reflects the specialized hardware and control logic needed for that ultra-low-power sleep state. It's the price you pay for that specific efficiency. A standard HDMI panel would be cheaper upfront, but the project would fail its core goal.
Okay, display sorted. What about the computer itself, the brain? They mentioned using a Raspberry Pi.
Yes, but here's another critical decision, #2. Choosing which Raspberry Pi. Specifically, the Pi 4 versus the newer, faster Pi 5.
Intuitively, you'd think faster is better, especially if they're calling it AI native. Why not the Pi 5?
It comes back to that prime directive, idle power. The Raspberry Pi 5 is, yes, significantly more powerful, but it also uses a lot more power when it's just sitting there.
How much more?
The numbers they cite are pretty stark. The Pi 5's baseline idle power draw is somewhere between 2.75 watts and maybe even 4 watts, depending on configuration.
And the Pi 4?
The Pi 4 Model B, the 4GB RAM version they selected, can be optimized to idle well under 3 watts, sometimes significantly lower with careful tuning.
But hang on. Is the Pi 4 really enough power? If you're interacting with an AI, like sending prompts, getting responses back, won't that feel sluggish, especially if they're planning to underclock it for power savings?
That's a fair question. The justification in the blueprint is that for this specific workflow command line, text editing, maybe some light compiling the Pi 4, is perfectly adequate.
Oh, so?
Because the heavy lifting for the AI native part isn't happening locally, they plan to use something like the Gemini CLI, which means the actual AI processing happens in the cloud. The Pi just needs to handle sending and receiving text, running Vim, running tapemux. The bottleneck isn't usually the CPU, it's how fast you can type or read.
Ah, okay, so the local load is actually quite light.
Exactly. And that lower idle power baseline of the Pi 4 is paramount for overall endurance when the device spends most of its time waiting for you.
Yeah.
They chose longevity over peak speed.
Makes sense for a deep work machine.
Okay.
Okay, so we had the screen, the SPC. What about keeping it all powered? The battery system.
Right, the power delivery network. They needed a solid battery capacity, obviously. They estimated the system's maximum continuous power draw at around 3.5 watts.
So, doing math.
Based on that, they targeted a 10,000 milliamp hour or 37 watt-hour battery capacity that gives them roughly 8 to 10 hours of continuous worst-case usage.
But the goal is that it's rarely drawing that much because of the ink and idle states.
Precisely. That 8-10 hours is the floor. But just sticking a big battery in isn't enough. You need intelligence.
How do you mean?
You need a way to manage charging safely, prevent over-discharge, which kills lithium batteries, and, crucially, let the operating system know how much juice is left.
So it can shut down gracefully before the power just cuts out.
Exactly, preventing data corruption. For this, they use another HAT, a UPS-HA uninterruptible power supply.
Like a mini UPS for the Pi.
Kind of. It sits between the USB-C power input, the battery, and the Pi. It handles charging logic, battery protection, and it has a communication interface, usually I2C, so the Pi software can query the battery status.
Which specific parts did they spec out for the UPS?
They mentioned the WaveShare UPS HATD, and for the batteries themselves, two 5,000 mAh 200 and 700 Leon cells.
201700s, not the more common 18650s.
Right. 201700s generally offer better energy density. Again, it's that relentless optimization, squeezing more power into the same space or weight. Efficiency over convenience.
Okay, power sorted. What about actually interacting with this thing, the keyboard?
The human interface device, yeah. Needs to follow the same philosophy. They opted for a mechanical keyboard.
For the typing feel, presumably. Writers and coders often prefer them.
Better typing feel, yes, but also durability. They specified a compact 60% layout, no number pad, maybe no function row, keeps it small.
And power-wise.
Critically, a wired model, no Bluetooth radio sipping power, and absolutely no keyboard backlighting. That's another huge power drain, so disabled or just not included. Every single milliamp counts.
It really is a design philosophy carried through every component. What about the case? Holding it all together.
The chassis. Needs to be custom, obviously, to fit these specific parts together snugly. They plan on using 3D printing.
And prototyping flexibility.
Flexibility and cost-effectiveness. They specified PTG filament, which is a good balance of durable and relatively easy to print. It lets them iterate on the design to get everything integrated perfectly. The screen, the Pi, the battery HAT, the keyboard mount.
And the final cost. With all these specialized parts, like the e-ink HHE, does it become prohibitively expensive?
Surprisingly, no. The bill of materials summary in the blueprint estimates the total prototype cost at around $628.
$628?
Yeah.
That's actually pretty accessible,
Mm-hmm.
especially for such a unique, tailored device.
Yeah, keeping it well under their $1,000 target was important. It makes it feasible for the open source community they're trying to build around this.
Okay, the hardware seems incredibly well thought out, driven by that efficiency goal.
Yeah.
Now, how does the software bring it all together and deliver that AI-native experience?
Right, the software. This is where the hardware choices enable that specific, focused workflow. It all starts with the operating system.
Which is?
Minimal Debian, specifically Raspberry Pi OS Lite. The Lite version means it's headless by default, No graphical desktop environment, no unnecessary background services chewing up RAM and CPU cycles.
So you'd set it up initially over the network using SSH from another computer.
Exactly. You don't even need the e-ink screen connected for the basic OS install. But then comes the first major software hurdle.
What's that?
Getting that special e-ink screen working. Remember we talked about the SPI connection?
Yeah, the low-level control for power saving.
Well, that means it's not plug and play like an HDMI monitor. You have to install specific drivers.
Okay. What does that involve for someone following this blueprint? Is it complicated?
It's probably the most technically involved step. You need to mess with the Pi's configuration files to enable the SPI hardware interface at the kernel level.
Sounds a bit deep.
It is. Then you usually need to download the screen manufacturer's driver libraries, often provided as C source code, and compile them yourself right there on the Pi.
Compiling from source. Okay, so definitely not for beginners.
Not entirely, but it requires some comfort with the command line and build tools. It's essential to get the OS talking correctly to that specific waveshare controller to manage refreshes and, crucially, enable that deep power-saving sleep mode.
The blueprint mentions a verification step here. Testing the screen.
Yes, and that's smart. Before building the whole user environment, they recommend running a test program that just cycles the screen through different patterns to confirm the drivers are compiled and installed correctly, that the hardware connection is good, and that the refresh performance is acceptable before you start layering Vim and everything else on top. It isolates potential problems.
Okay, assuming the screen works, now we get to the really unique part, the AI integration. How do they make a command line Pi AI native?
This is the core innovation, I think. They integrate AI, specifically Google's Gemini, directly into the command line workflow.
Using what?
The Gemini CLI command line interface. It's an official tool from Google.
Okay, how does that work?
First, you need Node.js installed on the Pi, version 20 or higher. Then you use NPM, the Node Package Manager, to install the @Google Gemini clan package globally.
So the AI becomes just another command you can run in the terminal.
Exactly, like else or grep or git. You now have a Gemini command. You authenticate it once, and then you can interact with the AI directly from your terminal.
But the real magic is how they integrate it with the editor.
Right.
Avoiding switching windows or copy-pasting.
Yes. This is where Vim comes in. The blueprint highlights using Vim's built-in capability to run external commands. It uses the dot command.
How would that work in practice?
So imagine you're writing something in Vim. You could select a paragraph, then type a Vim command like .gemini generate, summarize this selection, or critique this argument.
And the selected text gets sent to the Gemini CLI.
Exactly. It pipes the selection as input to the Gemini command. Then you could even use Vim's R command, read from external command, to pipe the AI's response directly back into your document, replacing the selection or inserting it below.
Wow. Okay, so you literally never leave your editor. The AI is just a tool you call on, like spell check, but infinitely more powerful.
That's the idea. A truly seamless AI native editing experience, all within the focus-enhancing confines of the command line and Vim. No browser tabs needed.
That's pretty slick.
Yeah.
But they take the workflow automation even further, right? The instant-on idea.
Yeah, they want the device to be ready the instant you open the lid. No waiting for boot sequences, no logging in, just straight into your work.
How do they achieve that? Need some hardware-software link.
It does. It's actually quite clever and low power. They use a Hall effect sensor.
Like the sensors in flip phones or laptop lids that detect closure.
Exactly. A tiny magnet in the lid, a tiny sensor near the hinge connected to the Pi's GPIO pins. Very low power draw.
Okay, so the sensor detects the lid opening, then what?
A small Python script runs in the background as a system service using systemed. This script just constantly monitors the state of that GPIO pin connected to the Hall sensor.
And when it detects the lid opening,
it executes a command. And this is where Tmux becomes essential.
Ah, Tmux. Tell us about that. It's a terminal multiplexer.
Right. Think of it like virtual tabs or windows within a single terminal connection. It's crucial for a command line only environment.
Why crucial?
Because it lets you manage multiple tasks and persist your session. The script that runs when the lid opens can automatically start Tmux or attach to an existing session if one's running.
And within that Tmux session,
it can automatically open Vim, maybe load your last project file, and even open a separate Tmux pane running the Gemini CLI in chat mode.
So you open the lid and boom, you're instantly looking at your code or text with the AI chat ready in another pane exactly where you left off.
That's the goal. Tmux keeps that whole environment alive, even if the system sleeps or you detach. No setup time, no context switching, minimal cognitive load, just immediate deep work.
That combination of the Hall sensor, the script, and TMUX is really elegant. It turns the physical act of opening the device into launching your entire focused workspace.
It's peak workflow efficiency, but underpinning all this is still that core need for power efficiency. They have a whole section on really deep optimization.
Going beyond just choosing the Pi 4.
Oh, yeah. We're talking kernel-level stuff now, extreme power optimization.
Okay, what kind of tweaks?
First, disabling hardware you don't need. This involves editing bootconfig.txt, a core Raspberry Pi configuration file.
What can you disable there?
Things like the HDMI ports if you're only using the e-ink screen, the onboard Wi-Fi or Bluetooth if you're using wired connections or don't need networking, even the little onboard status LEDs. Anything that draws even a tiny bit of power unnecessarily gets cut off at the kernel level.
Serious stuff. What about the CPU itself? You mentioned underclocking.
Yes. Also typically done in bootconfig.txt. You can set lower maximum clock speeds, and you configure the CPU frequency scaling governor. It controls how the CPU changes its speed based on demand. You want a very aggressive power-saving one. Options like Power Save, which locks the CPU at its lowest speed.
Which might feel slow sometimes.
Potentially. Or On Demand or Sedutil, which try to ramp up speed only when needed and drop back down instantly. The goal is to spend as much time as possible at the lowest possible frequency.
And they even mentioned disabling CPU cores.
For truly extreme savings, yeah. You can modify the kernel command line in bootcmdline.txt to tell Linux to only activate, say, 1 or 2 of the Pi's 4 cores. If your workload is purely single-threaded text editing, why power the other 3?
Ruthless. Okay, one last bit on software. Managing that battery safely. How do they prevent sudden data loss if the battery does run out despite all this?
Critical point. They rely on that UPS HAT we talked about, the one with the I2C interface.
Right, so the OS can talk to it.
Exactly. You need another background script, probably Python again, that periodically queries the UPS HAT over I2C to check the battery voltage.
And translates voltage into a percentage.
Or just triggers an action when the voltage drops below a predefined critical level. When that happens, the script initiates a clean, orderly shutdown of the operating system. Sync, unmount file systems, power off safely.
Preventing that horrible moment of the screen just going black mid-sentence and corrupting your work.
Precisely. It's the safety net that makes these extreme power optimizations viable.
Okay, so we have the philosophy, the hardware, the software. It feels like a really complete vision. But you said earlier it's more than just a blueprint, it's a call to arms.
Yeah, the manifesto is very clear about this. It's fundamentally an open source project. They are explicitly not looking for traditional venture capital.
No Shark Tank pitch, then.
Definitely not. They're looking for partners in creation, people who believe in the vision and have the specific skills needed to bring it to life.
Because it's too complex for one person to build alone.
Absolutely. The range of expertise required is huge. So they actually break it down, outlining 5 essential roles they need collaborators for.
Okay, what are the roles? Who are they looking for?
Role number 1 is the Debian sage. This is the deep Linux expert.
It's a kernel hacker.
Pretty much. Someone who lives and breathes Debian on ARM processors, who can wrestle with kernel optimization, compile drivers from source, squeeze out every last drop of power efficiency. They're building the soul of the machine, that rock-solid, ultra-efficient OS.
Got it. Role 2.
The master fabricator. This is the industrial design and 3D printing guru.
The one who makes the case look good and not fall apart.
Exactly. Someone passionate about design, experienced with CAD software and materials like PTG, who can create a chassis that's elegant, durable enough for outdoor use, and perfectly integrates all those specific off-the-shelf components.
Makes sense. What's next?
Role 3 is the supply chain diplomat. This tackles that big price tag we saw on the e-ink screen.
The $408 component.
Yeah. This person needs connections or experience in the electronics industry. Their mission is to negotiate with suppliers, maybe Waveshare or others, to try and get bulk discounts or partnerships to bring down the cost of that critical screen. Making the whole project more affordable and accessible is key.
A crucial role for scaling up beyond a prototype. Okay, number 4.
The community champion. This project needs a voice and momentum.
Someone to manage the open source community.
And potentially run crowdfunding. Think Kickstarter or something similar. They need someone skilled in communication, marketing, community management to rally support, answer questions, and be the public face of Project Scribe.
Builds the army. And the 5th role.
The AI evangelist, because this is positioned as an AI native device.
So someone to connect it to the AI world.
Precisely. This person needs to be able to articulate the vision to the AI industry itself, to companies like Google, Anthropic, OpenAI. The pitch is, you're building these amazing AI models. Here's the perfect hardware for humans to interact with them for deep, focused thinking and creation.
Trying to get buy-in or maybe even funding from the AI side.
Maybe. They frame it as seeking investment that represents good karma, funding a tool that helps humans think better, which ultimately benefits AI development too. It's about completing that feedback loop.
Wow, that's a really comprehensive view of the collaboration needed, from kernel code to industry partnerships.
It shows they understand the scale of the challenge. It's not just a technical project, it's a community and logistical one too, all unified by that core idea. Focus is precious, and our tools should protect it. #outro.
So wrapping this up, Project Scribe really feels like a complete, thought-through plan. It's not just wishful thinking.
No, it's quite grounded. And it all stems from that core philosophy. In today's world, being able to focus deeply is like having a superpower.
And they've proposed achieving that superpower through a really tight synthesis, combining the right hardware, like e-ink,
with the right interface, the command line,
and layering on a modern AI-native workflow directly inside the editor, like Vim.
Eliminating distractions, eliminating context switching. Every single engineering choice, from the Pi 4 over the Pi 5 to demanding SPI for the screen to underclocking the CPU, it's all in service of that one goal, enabling long periods of uninterrupted, deep work.
Which brings us to our final thought for you, the listener, to mull over after this deep dive.
Yeah, think about the core design here. Project Scribe aggressively limits output channels, no distracting videos, no complex web browsing, no social media feeds baked in.
While simultaneously trying to maximize focused input and processing just you, your thoughts, the text, and the AI assistant.
So the question to ponder is, if your primary tool was fundamentally built only for creation and deep thinking, and actively blocked out digital consumption, how might that change the actual quality and depth of your own original work, your learning?
Does that kind of engineered, hardware-enforced simplicity inherently lead to, I don't know, more complex, more valuable thought? Could stripping away features actually make us think better?
It's a fascinating question in our age of digital maximalism, something to definitely chew on.
Indeed. Well, that's all the time we have for this deep dive into Project Scribe. Thanks for joining us.
See you next time.